Welcome back to VTU e-Shikshana program on computer-aided engineering, graphics or drawing. We are working on module 4, that is isometric projection, wherein we have taken the basics and also individual prisms, pyramids. Now we are working on the combination of solids. I have two typical problems to solve today. Now let me take the problem. A cylinder is vertically placed on a rectangular face of hexagonal prism. Axis 80 mm long and the side is 30 mm. Now I will show the model. Very simple. I have hexagonal prism and these are rectangular faces. That is lateral faces if you keep it in any position. Okay, this is top face and base. Okay. Now I will keep the cylinder on this. The dimension of the cylinder is 30 mm and height is say 60 mm, and the base side is also 30 mm, so that it coincides. The diameter ends coincides with this. Sometimes it may be smaller than that also. So this is the model I have centrally placed. So this is how to work this problem, an isometric projection. So if you want isometric projection regular, you have to convert that into the isometric scale and do it. Now I will do only drawing or the projection, isometric drawing. Okay. Now if you want, you can convert that into isometric scale in computer, multiplying by 0.816. Now how to start? Let me take this particular figure and enclose this in a box. So keep this in a box so that we don't know how to draw the hexagon directly. So name it as 1, 2, 3, 4. 1, 2, 3, 4. Next comes the cylinder. You don't need any reference. Its pi is there, that box is square. You can always work out by 4 centers method. Now let me take this 2 as reference. Let me draw the vertical line. This is 2. Since the face is vertical, so you have to get the isometry on the vertical surface. So one is horizontal, other one is vertical. Now this is 30-degree line. I can draw 30-degree line like this. Okay, take 30-degree line from this point, 30-degree line. So actually you have to measure 30-degree line like this from horizontal. Draw a line like this. Then measure this distance. Now take this distance and mark. Okay. Now draw this vertical, horizontal. Complete this parallelogram. So see that this is 2, this is 1, and this one is 4. This is 3. Either way it works. 1, 2, 3, 4 better because it is front view. 1, 2, 3, 4. Let me take this becomes 3. This is 2. This is 1, and this one is 4 for better understanding. Identify the points. This is A dash, B dash, C dash, D dash, E dash, F dash. This is characteristic feature of hexagon. If you have 30, total becomes 60. This is 15, 15. So it is very easy to identify. Take 15, 15 both sides. In computer you mark 15, draw vertical. That means parallel to this. Again take 15, draw vertical. In one go you will get 4 points. So this is, let me identify this as this is B dash, this is C dash, this is D dash, E dash, F dash. Now this is B, this one is C, this is D. Midpoint automatically you get in computer. and this is E, this one is F, this is A. Join them in order. Similarly, you try to work out at a distance of 100 mm or 80 mm. So in computer you can move and rotate, that's all. Sorry, move and fix. Here it is, again you have to repeat manually. Say draw 30-degree lines and fix the same pattern 30 parallel to it. If you have roto scale manually also it's easy. You can move and draw parallel lines. Okay. Now you can fix the points like this. Points as in the first case. Join them. Light line to start with. Keep light lines. You get same size, same figure. Now I join this BB1, CC1, etc. I join. This is B1, this is C1, this is A1, this one is D1, this is E1, F1. Join BB1, CC1, DD1, E1. And also AA1 also. It's not visible, still FF1 also you join. Now the interested surface is this top rectangular face. This is the top rectangular face. Other faces also to be marked dark line. Boundary lines dark. Front surface is visible. Boundary lines dark. And DD1 is visible because it is crossing the invisible surface or bends. It works in a majority of the cases. See, front surface, colored one. This is the one which is light is front surface. This is dark. I am looking at this. So the front face is visible and this one is not visible for this. Okay. So I have completed this one. Don't draw any dotted lines. Visible edges all completed. How to place the cylinder exactly at the center of the rectangular face. So what you do is identify the center point, draw a line, again identify center point. In computer automatically you will get the midpoint. If you move here with a line reference, automatically you will get the line midpoint, you join these two, again midpoint, join this will get the center. Now in this case, in my case, I have taken 30 exact, so already this is 30, you take 15 each here, draw lines, light lines. Then 4 centers method, complete the ellipse. See that this should touch, these two lines should touch. Then go up by given value 40. Then draw again 30-degree line, 30-degree line. This is the problem with the manual thing. In computer it is easy. You move up, fix it, that's all. Same figure. 15, 15, so 30. Draw midpoints with the opposite obtuse angle corners. Then fix the ellipse. Then draw 2 vertical tangents. Draw 2 vertical tangents. Then complete the top face, visible ellipse. Again part of this is visible. So top solid is over. Now what about base solid? Yes, base except this portion and completely whatever we have darkened, it's visible. So let me keep this light. So in computer, whatever is there you split at this point, again split at this point, converted that into light line, that's all. So let me make it block now. So then I will trace it again with the red color, whatever is required. Okay. Now this is dark. Then front surface completely dark. Yes. Longer edges DD1, then FF1, sorry, EE1, and sides, radiant sides. This is radiant, this is front end. So that's all about the isometric projection. In wordings, they may give a vertical cylinder is centrally placed on a rectangular face of hexagonal prism. Okay, definitely they will give one of the view like this. Otherwise, they will give in words. You can understand better. So dimensioning, minimum dimensions you do, this is 40 and this is 30, etc. So that works for the minimum awareness on the thing. Say this is say 30, and height or the axis length 80, whatever is given, and this height can keep vertically 40, and here you say 35. That's all, nothing else. Okay, side and length, and here diameter and height. That's all. So this is about the figure 1. Okay. Now what about figure 2? So figure 2 have the problem with two cones which are placed at diagonally opposite corners, and this is square block of 90 mm sides. Say, let me say 90 mm sides. Okay, and here this is 30 dia, 30 30 gap of 30. Okay, assume that this is 30. It's little more is there. Now to draw it, it's again simple to draw the isometric projection or view of a square block. I told you, I repeated many times, you draw plus mark. Plus mark is best mark in graphics all the time. 90 is there, you take off of it. Take off of the distance and mark. Say, they, for example, have this, okay, 40, yes, little more, off, take off of the distance, then take total, whatever is available. With compass, take total. With this or this as center, draw. Don't, not with this center. Now draw arcs. Then join these lines. Within no time we can complete this. Okay. Now, since it is block, I don't want to have complete base or top face. Assume that this is top face of the block. So yeah, this is the, assume that this is the square block. I have drawn this top face. I'm going to keep the cones here, the two opposite ends, I mean diagonal opposite corners nearing that. Now, you keep only the visible edges, that's all, vertical edges. Now, let me take this, whatever is given, say 20 height, thickness is 20 for the square, and this height of this is 40. Now, take 20 each. Yes, join this. Now, keep the cones at these two corners. So, let me name this as 1, 2, 3, 4 corners. So, assume that you are looking from this direction. Yes, this is 1, this is 4, this one is 2, this one is 3. At 2 and 4 you have to keep it. Yes. Again, take this 30 and draw this one. Again, draw this. Four centers method. You will get the ellipse here. You see that it will touch the sides of this. Then go up by given value 40 height with the axis representation from the center. Draw tangents. Again draw tangents. The height. Must be very careful. Tangent must be drawn not with these two corners, diameter lines. Now let me complete the figure. In computer, what best you do is do only this. Complete only this figure. Copy, move at this point. I will show you how exactly you can do on computer. It's a very easy job. Now visible, adjust. Now keep this lines dark up to tangent point. Then dark the remaining portion. Again, same thing you do here. Tangent point, then portion which is. Next, this portion is visible for the block, square block. Back side, rear sides are visible. Then front sides completely visible. Yes. Now this small portion, don't forget. Either side, then draw vertical lines. Then finally complete the base edges. So this is how you can complete figure 2. I will repeat. Let me confirm. These are the two cones placed diagonally opposite corners. Reference 15 mm from each side, that becomes the center. Height is 40 and this is the square block. So how to work on computer? I will show you in the computer. Okay, let me take the problem on combination of solids for the asymmetric projection. You have a cylinder placed on the rectangular face of the hexagonal prism. Okay, actually axis is horizontal. Naturally the rectangular surface, one rectangular face is on the ground, opposite rectangular face is facing the sky. So naturally you have to place this, the cylinder centrally, okay, on the prism, on the rectangular face. So this is what the side view. If you keep the front view like this, then definitely the corresponding cylinder front view is there. So with respect to this, I have to start working for isometric projection. So what I do is, whenever you get other than square and rectangle, definitely you must go for the box. So here is the box for hexagon. Hexagonal shape is A, B, C, D, E, F. Then 1, 2, 3, 4 is the box for that. Now let me take this as reference. This is vertical, this is horizontal. Again this is horizontal, this is vertical. So what I do is, I will take this vertical line and this as horizontal. So this is 3 for information. This point is 3, starting point. Then 30-degree line, vertical line. So this completes the isometric projection of what is called the rectangle, 60 by 51.96, that is almost 52. After drawing this, you have to identify the corners of this. So actually this is very interesting in case of hexagon. This is 30, the total length becomes 60. Either side you have 15, 15. So what you do is, you mark 15 mm, here 15 mm, draw verticals. Definitely you get the other points. This is actually BC and this becomes your FE. So what about B and D, A and D? Automatically you will get, once you, I will show you how to get the hexagon here. So I have marked FE, equal distance. Again draw vertical lines are parallel to these lines. You will get automatically BC. Now how to draw vertical, the hexagon? Now I will take this thin line basically, yes. Now start with this. Or I can start from A only. A is automatically midpoint you get. A, this is B. This one is C. This one is D. Automatically you will get, should show the midpoint. Then E. This is F. This is A. So this is what I got from this. Next, what you have to do is, you have to have, this is front end of the hexagonal prism. rear end of the hexagonal prism at a distance of 80 mm say. Okay, so 80 mm or 100 mm. So let us take the value of 100 mm, draw a line from this corner and then create the same thing here. How to do it? Manually you have to do, you have to work out this. But here in case of computer, what you do is you move and rotate, that's all. Move and fix, not rotate, move and fix, that's all. Where to fix I will tell you. So you move this, see this must be complete, this one, shaded. Then you move this, take to the end point of the line. That's all you have to do. Then join all these cards. This is AA1, BB1, CC1, DD1, EE1, FF1. Join them. You will get the respective longer edges. So that's what you have to do. Here I have done this job. Next comes draw lines one by one. This is AA1, BB1, CC1, DD1, EE1, FF1. Then visibility concept. The front end is visible. The boundary lines are dark. Okay. Then invisible surface and invisible lines. I will do that for you. Select this front end lines. Dark it. First thing is front end lines you dark it. Purposefully I am taking big thickness, that means log thickness little more so that you can realize. Now boundary lines dark. Actually you have to take 0.5. Boundary lines dark. Now these lines, this is A, B, C, D. This is CC1, DD1 are visible because it is crossing the invisible surface. This is how you can realize. So this is what the requirement for us. The hexagonal prism is placed horizontally. The axis is horizontal. And the one rectangle surface on ground, other one is facing the sky. That's all. Now, this is what you have to do. Here I have taken 0.5 only. Just for explanation I have done that job. Next, how to identify the center of this? Because you have to keep this centrally on this. So midpoint, I will show you how to do it. See, here you move on this, you get midpoint. You move on this, again you get midpoint. Then you move on this line, that is I am concentrating on the top rectangular surface. Yes, you got the center. Then prepare the cylinder, isometric projection of cylinder and then move and fix it. That's all. See, I have created this and then I have also identified the center. So what you do? You take this move and rotate, move and fix it. Yeah, move and have this base center is coinciding with the top center of the rectangular surface. Center of the rectangular surface, top rectangular surface. See, like this. It is showing midpoint. Yes, that's all. Now I have retained this also. Actually, you have to keep this slide so that you can. So this is only for explanation purpose I am done. So now you do this. Now what about the visibility? From this point to this point, the longer edge of the top rectangular surface is not visible because the cylinder is placed there. Whatever it is behind the cylinder is not visible. Okay, so this is how you do it. See, you take this line, split, that's all. You will take this line, split at this point, again split at this point, so that you will get the final isometric projection. So if you want this isometric, this is isometric drawing, whatever the actual distance. If you want isometric projection, you try to reduce it by scaling. Here is the scale. You can take and do it. Okay, so that's what you can do. Go through the question properly. If it is view, keep it as such. If it is projection, you scale it and keep it. You will get smaller size. Okay. Now, the next problem is that two cones are placed with respect to two corners as shown in the figure. Two corners of the square block as shown in the figure. This is 90 square and this one is 30, height is 40. So how to do it? First you have to create the square block. Okay. square block is ready. You know how to create. And either side of this you have to create this one. So what I did, I have to create the cone here, and you need not do any procedure here. So now what I do is I will then remove it. Okay. Yeah. I don't want anything here. I will show you how to do it. You create only, take 30 degree line, 30, already these two are 30 lines. You take two more lines parallel to each other, parallel to the existing one, and then you get 4 centers method. You work out, you get ellipse in this one, and then vertical height 40, then draw tangents. Okay, then you can do separately, because here we have the facility. The thing is here you can create itself here itself. Then you move this side. But let me complete the visibility of the cone also. Yeah, you complete it and see that these are on this only you can do it. But let me remove this. Okay. Now how to transfer this again? The existing one and one more. Move and copy. Copy actually. Now what to do? See, you take this, move this portion, yeah, this portion with respect to a specific corner. See, I will take this corner. This corner should coincide with this corner. That's all. So this is what we are interested in. So see, this should be dark, and you took the end. That's all. So you have done only one and copied and got this. Okay. Then this is square block and these two are cones. Now, how to complete the figure? We have to dark the top edges of the square block, and also here two base edges and vertical line, 3 vertical lines. But here you see this portion is not visible because cone is existing there. Cone is placed there. So from this point to this point. Now, so this is how you complete. Dark this portion. Yeah, dark this portion. You try to split this and make this light. So this is how you complete the solution. Now minimum dimensioning you can do at the final solution. You can go for minimum dimensioning. Yes, this height 25 I have taken, and this is 40 given, and the square length only you can dimension, so that gets you the one. See here, square of 90 square, and this one dimensioning of this, see here it is 30. If this is 30, definitely the circle diameter is also 30. This also 30. Yeah, keep it outside always. So this is how you can complete isometric projection or view of a given figure as per the requirement. Distances and all will be given properly, and then you have to keep it. Now let us see some more combination of solids typical figures in coming sessions.